last but not least, please welcome Tahir from KRNL Labs.
Hello, everyone. Yes, sir. My name is Tahir Mahmood. I'm the co-founder of KRNL Labs. So let's start. Pretty much start with my background. I've been in the game for more than 40 years. I started writing code in 1979, did AI in the mid-80s, Lisp and Prolog. Ended up joining Microsoft as the lead for operating systems and programming languages in '89, helped bring out Windows 1, NT, OS2, so pretty much been in the game. I was building AI agents in telecoms in 1992, 93, 94. I invented push email that came BlackBerry and so forth. I helped scale the Halo engine to 1 million concurrent connections. All I'm basically trying to say, and I have a lot of patents, I know how to build global scale systems. That's really what I do, distributed and sort of operating system level. Carrying on, what is KRNL Labs? Well, basically, we all have to solve a problem. And the problem we're out to solve is centralization, which we know is the reason for blockchain and decentralization to begin with, fundamentally. Limited interoperability. We have so many L1s, L2s, we have Web 2, we have agentic agents, we have all these different eco-environments, but nobody's providing the glue. And it's interesting, there's a paper by Vitalik called to do with glue, and we're the answer really at that point. Opaque AI models. What do AI models do? You give them something, you know, all the different hidden layers do something and pops out a magic, some result. But how do you safeguard it? How do you govern it? How do you make sure that it's performing the way it should do? And that's, again, another big problem. Finally, quantum. You know, we are seeing quantum qubits and everything else. Kernel's technology is predicated on cryptography. So let's start with what we've done is we've created a system that pretty much allows you to use everything that you can bring into cryptography, but something more important. There's this technology called proof carrying code. People are not familiar with it, but in the mid-80s, when you were actually transporting code or doing something between one distributed system to another, you needed to make sure that it was actually executing as per the policies and the rules. And we've been able to find a way to embed that into AI. So AI models, the data that goes in, the data that comes out, the weights that are there, be able to produce hashes, check that if everything is according to plan. Okay, so we built what we call a KOS, operating system. We've literally opened the Geth node in Ethereum as our EVM compatible chains that we're starting with. We've embedded it. We use all the different technologies. We use GraphQL. We allow you to create a workflow and instrumentation using a DSL, domain-specific language. On the node itself, we decode that into a DAG for those directed cyclical graph, and then we're able to execute, and then we have an ability to attest that all the execution is correct. Finally, transparent.
Thank you so much. We'll have to stop here, but we'll have more time for questions. And I'd love to hear from you, Balmania or Nathan, please. Anybody would like to jump in first?
It's a complicated pitch. And super cool. Humble to be hearing from you. What does the product end up as, and who's it for? Is it a protocol? Is it is it?
So it's a protocol B2B for dApp builders, smart contract builders. So basically, we're middleware. And so what you're able to do is basically have a new form of our dApp that not only talks to a smart contract, but the smart contract can actually say, I would like on my behalf for you to execute any other smart contract on any blockchain, off-chain, bring the data, do a proof of execution, proof of correctness, and bring the data to me.
Okay, so a meta messaging sort of orchestration layer. How does the being able to hash an LLM's output relate to that?
So the idea being is that when you have AI models at this moment in time, they're just black boxes. You don't know how they're performing. So, and when they have produced an output, there's no timestamp. There's no way of knowing what was the data that went in, what did it actually produce, and what came out. So what we're doing is that's what we call anchoring or AI tethering, that when an AI model is executed by us in our kernel, we are able to extract all of that metrics and put it on chain, so you can then have accountability and traceability of how the AI model actually performed.
How do you get into the guts of the AI model? I mean,
So I'd go into the technicalities of it, but it'll take me a while to get into that. But I can tell you we've done it.
You mentioned that your solution is a protocol that is doing off-chain computing and on-chain execution and trust. But have you also benchmarked how Tease works and how do you could mix the off-chain part computing power with the on-chain trust, verifiability, and execution? Yeah.
Yeah, sure. So on the node, what we've written is there's no real latency. What we've done is we use GraphQL with custom resolvers, and we go out to different RPC nodes and basically stateless read, which is very, very quick. For off-chain, we provide an API key as part of an open API spec, and that goes out and that brings the data from Web 2 world. Now, obviously, the use cases are if you want an application that's highly performant based on DEXs or something else, then you would not necessarily choose certain functions that are available, but we give you a chance to use everything that has been created by the community, and you can monetize on that function.
Thank you so much. Please, a thunder for applause for KRNL Labs. Thank you very much, Tahir.
Oh, one last thing. If anybody wants some T-shirts, I brought some.
Thanks a lot.